Okay, boys, we were doing the chapter fluids in motion, and in the previous class I taught you about the steady flow and the rate of flow definition. I said rate of flow denoted by capital V, and that means volume of the fluid flowing per second. Volume. It is not the speed. And the capital V can be written as A and small v. A is area of cross section, and V is the speed or velocity of the fluid. And for a steady flow, the rate of flow is constant. That is capital V is equal to constant, or AV equal to constant, or A1 V1 is equal to A2 V2. From this relation, we conclude that where the area of cross section is less, usually it deals with a pipe and all, like where the area of cross section is less, the speed will be more, and where the area of cross section is more, the speed will be less. But this is only applicable for steady flow, and this equation A1 V1 is equal to A2 V2 is called equation of continuity. And last class only I discussed with you the reason type question, no, like why from the showers and all, no, showers has got small holes, water comes out faster, high speed, because they have got less area, more speed. Burners, gas oven burner and all, the small holes are there so that the gas comes out faster. Gas comes out faster. And you have a narrow pipe, you have a thick pipe. Narrow pipe, the speed will be more, and the thick pipe, the speed will be less. So we discussed all these cases, no, last time, result and question on it. Okay, today we are doing an important topic. It is called Bernoulli's theorem. Bernoulli's. Give the heading Bernoulli's theorem. Bernoulli's theorem. Okay, before I give you the statement of this theorem, I'll just tell you something and then I'll give the statement because easier. Okay. When a fluid flows, fluid will have three kinds of energy, three types of energy usually. It will have a potential energy, that is MgS. It will have kinetic energy, motion, fluid in motion, it has motion, so it will have kinetic energy, half mv squared. And it has also a pressure energy, because liquid is exerts pressure. And it may have the atmospheric pressure acting on it. And what is the formula of pressure energy? Is maybe a new term for you. We have potential energy, we have kinetic energy, we got pressure energy. And pressure energy formula, do you know, does anybody know the formula of pressure energy? Pressure energy. What is the formula of pressure energy? Does anybody know? Energy due to pressure. It's called pressure energy. Does anybody know the formula of pressure energy?
Mass into
Anybody?
volume.
Just tell me. There is no harm if it is wrong also. If you know, then just share with me. Or at least say we don't know.
I don't know.
You don't know.
Yes. Boys, please. One of you at least say no. You know or you don't know.
I
If you
don't
know,
know.
just share.
I don't know.
It may be wrong. I'll correct it.
I don't
And
know.
if you don't know, say to me that also. Then I'll tell you.
So don't
Yes.
I
know.
don't know.
So,
I don't know.
Nobody wants to
so
say.
So we are saying
So we are saying your record. So your
Alright.
mark.
At least
So
say no, you don't know.
your headphones. So we are
so
saying
Come on, boys. Are you able to hear me? Am I audible?
yes, sir, you are audible, but
yes,
Boys,
sir.
we are not audible to you.
am I audible to you?
yes sir.
So
No.
Ki
Arabia? Tell me your answer.
Hello,
We
Sir.
don't know how to do.
Something wrong with this pen. I'll connect one second. Yeah, hello. Yes. Tell me the
Yes,
answer.
sir.
Does anybody know? Huh? Yeah. What
Don't
is the
know.
answer? Pressure is.
sir.
Okay, you don't
Don't know.
know. Yeah. Okay, okay, no problem. Pressure energy formula is PV. PV for pressure energy. P means pressure and V stands for volume. Volume. And it is applicable for a fluid. It is applicable only for a fluid. Fluid means gas and liquid. Can you check whether pressure energy formula is PV or not? The reason is I'll tell you. Pressure means force by area, no? And volume formula is area into the length of the distance. P and A cancel. You get force into a length, length with distance. Force into distance gives what? Work. Then with this pressure, the fluid is able to do this much work, and work then measurement is energy. Just keep in mind, and dimension will be same as the dimension of energy. What is the formula of pressure energy? PV. Understood? Now, if I ask you, please tell me that you know it. Yes? What is the formula of pressure energy? Tell me.
Okay, the
PV.
PV. Good. Okay. Now, just have a look at it. Huh? I'll take potential energy. What is the formula of potential energy? Tell me. What is the formula of potential energy? Say first. General formula for potential. I'm not talking about gravitational potential with respect to the
So
Earth.
MGH.
MGS. Good. MGS. Okay. But if I do potential energy per unit volume, if I do it per unit volume, that is this thing you divide by volume. Volume. You have to divide by V. V means volume. And do you know mass by volume? Mass divided by volume, what does it make? The formula mass by volume is the formula of what? Do you know?
Density.
Density. Density, yes. The mass by volume will be written as density, and density symbol we write as this kind of symbol, rho. In class 9 and all, we should write D. D means density. But now the formula will slightly change. Mass by volume is making rho. We write a rho GH. So what is the formula of potential energy per unit volume? Rho GH. Mass will be changing into density because volume value taking per unit volume is per 1 meter cube of the volume. That is, mass will be same as density. Have you understood? Any doubt, please ask me. Okay, don't keep it with you. All right. Yes,
Yes.
boys. Okay, okay.
Yes, sir.
Please respond. Otherwise, I'll be sticking wall, windows, and all only there. Okay. If you don't respond, no, it becomes monotonous for me. Yeah. Please keep responding. Keep interacting. Yeah? Same way, kinetic energy. What is the formula of kinetic energy? Tell me. What is the formula of kinetic energy? Half mv square,
PV
isn't
square.
it? But I take kinetic energy per unit volume. Per unit volume. What will be the formula now if I take? Can you guess? What will be the formula? Half.
half MV.
Half mass will change into density. No, we like half rho v square. This thing divided by volume, you know, divided by volume. Mass by volume making rho. Yes or no?
Sir, why it's divided by
Yeah.
volume?
Kinetic energy, what I have taken here.
So volume.
Then you will not divide by volume.
Oh, okay,
Okay?
sir, understood.
Pressure energy. What is the formula of pressure energy? Tell me. What is the formula of pressure energy?
So
Tell.
PV.
So PV.
PV. PV. But if I take it per unit volume, what will the answer now? This thing divided by volume. Volume cancel. What is also left over? P. Yes. You understood it? I am taking all the energy values per unit volume, per unit volume, per unit volume. Ah. Yes.
Yes, sir.
Yes, boys. Say fast, no, come on.
Yes, sir.
Okay. Bernoulli da. Okay, he's my brother. Okay. Bernoulli da said. Bernoulli da said. Okay, please listen. Bernoulli da said. I'll give the definition. I mean statement. Okay. First listen. Bernoulli da, not me, my da. Okay. Bernoulli da said the total energy of non-compressible liquid per unit volume remains constant. He said that. That means this value plus this value plus this value per unit volume is constant for what kind of liquid or for what kind of a fluid non-compressible and non-viscous means the fluid which is non-viscous, which is not sticky. The total energy per unit volume remains constant. Total energy means this energy, potential energy, kinetic energy, pressure energy, but per unit volume is said. Now write down the statement. Write down. It states that the total energy of a non-compressible comma non-viscous
Vegetarian.
VISCOUS non-viscous fluid in a steady flow remains constant throughout okay. Therefore you write like this. Therefore total energy per unit volume equal to constant total energy per unit volume is, you will be writing like this: rho gh plus half rho v square plus p equal to constant. Potential energy, kinetic energy, pressure, but per unit volume. That's a rho is coming. This is P. P means pressure only pressure. Capital P, this is for rho, but this is P. P means pressure. It's constant. You can write here for 2 points. You will be writing this rho G H1 plus half rho V1 square plus P1 equal to rho G H2 plus half rho V2 square plus P2 for 2 points at different heights and different velocity and at different pressure. This statement is called Bernoulli's theorem. I think you know who is Bernoulli, huh?
Yes, sir. Yoda.
Yes, very good. Yes. Okay. Done, boys?
Yes, sir.
Okay. Now, there is a derivation, formal derivation of Bernoulli's theorem, but derivation we will not do, okay? Because no MCQ things are there, so just learn the concept. Derivation of this particular theorem, not needed, okay? Now, as per, the new pattern or new syllabus, this is not required. So, I'll just explain to you the uses of Bernoulli's theorem, okay? All right.
Yes, sir.
Yes.
Yes, boys. Okay, and Bernoulli's theorem is a consequence of law of conservation of energy. It satisfies or it is a consequence of law of conservation of energy. Please, you can write that also. This type of question also had come in competitive exams and all. Bernoulli's theorem is a consequence of law of conservation of energy. Law of conservation of energy. Done?
Yes.
Pardon.
Now give the heading. Conservation of energy, law of conservation of energy. Just had applications. Applications, of course, application of this theorem only, applications of Bernoulli's theorem. Applications. Okay, applications. Ready? Say
Yes, sir.
fast. Okay, that is applications of what? Application of Bernoulli's theorem. Okay. Right, number one. Expression.
Okay, sir.
Okay. Expression for pressure exerted by stationary fluid. I think in lower classes, you had learned the formula of pressure exerted by a liquid. What was the formula? Do you remember it? In class 9, I think I only had taught the formula of pressure exerted by a fluid or a liquid. What is the formula? Do you remember? Tell me. If you don't remember, tell me that also.
Sir, mass into volume.
Pressure formula. Come on.
Force upon area.
That is force upon it. I'm talking about liquid, pressure exerted by liquid. Do you remember? P is equal to HdG.
Something with Bowen force.
Yeah, P is equal to HdG. H is the height of the liquid column, D is the density, and G is the acceleration due to gravity. Do you remember this formula, HdG? Or DGH? Those days
Yes,
I used to
sir.
call it DGH.
DGH.
Yeah, DGH, yes. So the same formula we are deriving but using Bernoulli's theorem. We can write P is equal to H rho G. D is same as rho. Now we will not be using a symbol small d. For density, I'll use rho like this. Let us prove this formula by Bernoulli's theorem. Okay. How we can prove? We'll take a container. Container is taken in which there is some liquid. The height of the liquid is h. This is called liquid depth of the liquid, or we can call it height of the liquid column. Suppose it is on some support here like this. It is on some support here, and the height. This height is h. This height of the liquid from the surface, from the ground level is capital H, till here. But what kind of liquid is this? The liquid is stationary. The liquid is kept in a closed container. Liquid is at rest inside the container. It's not moving only. It's just staying there in the container. Okay, that's why we are writing. I've written here expression for pressure exerted by a stationary fluid. I wrote this. Okay, now what I will do, I'll take this point as A, take this point as B. According to Bernoulli law, the energy at A and energy at B per unit volume will remain constant, isn't it? Am I right or wrong? We can write like energy at A equal to energy at B. Write on this. Energy at A equal to energy at B. Write it. All the point energy value will be same. Okay? Say okay at least. Yes, sir.
Yes, sir.
Okay. Okay. What is the formula of energy? Three types of energy. What are they? First, potential energy. Potential energy is derived as rho G. What is the height of this point above the ground level? Above the ground level, what is the height here? H. I like capital H. Plus kinetic energy. What is the kinetic energy formula? What is the formula? Half. Say
Half rho v square.
kinetic energy. Huh? Half rho v square. But kinetic energy will be there. No, because stationary, the liquid is at rest. No kinetic energy. I will not write anything about kinetic energy because the kinetic energy is zero at all points. No kinetic energy. Plus pressure energy. What pressure will be there at this point? At this point, the pressure, what pressure is reacting? What is the pressure of this point? Pressure of this point will be the atmospheric pressure. Atmospheric pressure here, like this. I like a PA, atmospheric pressure. Pressure exerted by atmosphere is on everything, so it is on this liquid also here. PA. Have you understood? Say fast. Okay?
Yes, sir.
Now energy at B. Energy at B, what is the potential energy? What can I write here? Take rho G. What is the height of the point B above the surface, above this ground level? What is the height?
H
Can you tell
minus
me?
H.
H minus H. Very good. That is capital H minus small h. Plus kinetic energy. Should I write any value for kinetic energy? No, because in liquid is at rest. What is pressure? What is the pressure of the point B? Can you tell me what is the pressure of the point B? Pressure of the point B will be atmospheric pressure plus the liquid pressure plus this pressure. So I'll be writing for this PA plus P. Because atmospheric pressure is always there. Atmosphere is always there and it's exerting pressure all the time throughout. Now I'll cancel P and PA cancel. We have here rho GH. Open bracket here you get rho G capital H minus rho G small h plus P. This rho G is cancelled. This will come this side. You get rho GH is the formula of pressure. Pressure exerted by a liquid. That's what we got. Now, in this formula or in this expression, you see what is rho? Density of the liquid or density of the fluid. It is applicable for fluid also. G is acceleration due to gravity, and what is h? Small h. You can see there in the diagram. Small h is the height of the liquid column. Small h is the height of the liquid column. It is not the entire height. The height up to which the liquid is there in the container. Liquid is contained in a container or in a vessel. That height, that is h. And that we call it height of the liquid column or height of the fluid column. We say that. Now the formula is proved. Done? Say fast.
Yes, sir.
Okay? This is how we prove the formula using Bernoulli theorem. Okay, next heading we give expression for a flux velocity, expression for a flux velocity. Okay, please see now what is a flux velocity. Yeah? A flux velocity time, what we will do, we take a container, maybe a big container, okay, big container, like a water tank and all, big. 1000 liter tank or 500 liter tank or maybe bigger capacity tank. And we'll make a hole over here. We'll make a hole. This is the point A and here is the point. Now the water will come off here like this. It will be falling down on the ground in this manner. Yes or no? When you make a hole, liquid will be coming out from the container through the hole. The velocity with which the liquid comes out, that velocity is called a flux velocity. Means at this point the velocity will be horizontal. This velocity will be called efflux. Velocity efflux at this point. Let us suppose the position of the hole is at a depth h, small h. I like this as small h. Small h is this one. From here till the hole, the distance or the height between the point, the upper surface of the liquid and the position of the hole, that h, that is h, height. Boys, did you understand the diagram?
Yes, sir.
Yes, we are not taking the entire height of the liquid column. We are not taking the entire height. We are taking the height from the free surface till the position of the hole, where the hole is made, or where the hole is drilled out. Okay. I'm writing the same. Total energy at A is equal to total energy at B. What energy does it have here at this point? Tell me what energy it will have? Rho G. Potential energy first. Rho G. What is the height of this point? H. And I say H. Plus, what is the value of kinetic energy at this point? Kinetic energy at this point is how much? Tell me. Is nearly zero. It's nearly zero because this kind of the water level will fall down very, very slowly, as if it doesn't have any speed, or the speed is almost zero. The kinetic energy of the point is zero. We don't see the movement of water, which is the level of water which is going down. That is kinetic energy of the point. This is zero. I can write as zero. You may not write this. What pressure energy will be there? P1 or PA. Atmospheric PM is atmospheric pressure. Now for the point B, I write rho G. What is the height of the point B? Capital H minus small h plus. But here through the hole, the velocity, efflux velocity, and the value which is quite high. With high velocity, the liquid will be coming out. Kinetic energy will be there at this point. I'll write that half rho V square plus pressure energy will be at this point only PA. Because this point is exposed to air, no hole. Hole is exposed to air. It will have only atmospheric pressure. Only atmosphere. Anything exposed to air will have only the atmospheric pressure. If anything is exposed or anything is below the liquid level, it will have two pressure, atmospheric plus the liquid pressure. So this hole is exposed to air only. Hole means air, no gas. So only atmospheric pressure. Let us simplify now. PA cancel. Here we get rho G H, open bracket, we get rho G capital H minus rho G small h plus half rho V square. This and this cancels. Rho G H will come this side. Rho G H is equal to half rho V square. Rho and rho cancel. Cross multiply, you get V square value is coming 2GH, or the value of V is coming root 2GH. And this is called efflux, velocity of efflux. This is the formula of efflux velocity. And in the formula you can see root 2G and H. What is H? Remember, H is not the height of the liquid column. H is the depth of the hole from the free surface of liquid. Depth of the hole from the free surface of liquid. That is why we say when the hole is at a greater depth, the value of V will be more. If the hole is situated at a lesser depth, the velocity will be less. And you know this fact. Through which hole, the hole at the bottom, the speed will be the highest at the bottom. That is the reason why in water tank and all, we always make a hole, or we make the outlet always somewhere near the bottom. Near the bottom we put the outlet, through which the water should come out with a high speed. If you put the outlet here, so speed will be less. Understood? Tell me. So this is the expression for velocity of efflux or efflux velocity. Yes. You have got any question? Say first. Okay, no. Then today we are doing till this much. Then tomorrow I'll continue.